All right, boys and girls, welcome to day one of section 4.5 graphs of sine and cosine functions. You can actually find these two graphs in your book on page 292. Okay, so it is not necessary to write into an index card because you can refer to your book, but it just gives you a reference of some things. Okay, so for example, this is the general form. I'm going to relate it to something that you've learned before in your past classes. Y equals sine of x is kind of like your parent function. Y equals cosine of x, again, is like your parent function, okay? So this is your sine of x, and I'm going to talk about some stuff. Your domain is basically all real numbers. Your domain, remember, are your x values. It's continuous. It goes all the way to negative infinity and it goes to positive infinity. So this pattern that you see here is continuous on both ends, okay? Your range, which is your y value, goes as high as 1 and as low as -1, okay? Which means your amplitude is 1, okay? Basically it's half the distance from your range values. And we'll learn about that and talk about that in a bit. Okay. Your range is 2 pi. So this is like your range. Again, think about it this way. I'm sorry, I said range, but I meant period. Your period is 2 pi. It's like one cycle. Think about it this way. It's kind of like looking at a window and you're only looking at this much. So that when we talk about period, it just pertains to that much. Because again, your sine graph is continuous. So we're only looking at it at this much. So that's what period refers to, okay? Think of it as if I were to graph it in my calculator, we're just looking at that window, okay? And then your x-intercepts, if you look at the sign, x-intercepts are like your roots or the points where it crosses the x-axis. They occur at -pi, they occur at 0, at pi, 2 pi, and they're going to be continuous, basically every multiple of pi, okay? Your y-intercept, where does it cross the y-axis? Well, that only happens at one point, at the origin, at 0, 0, okay? And this is considered an odd function. It's considered an odd function because on the y-axis, it crosses through the origin. So for example, if you look at the value to the right, your y value gives you +1. And then if you look at the value at on the negative side, your y value will give you -1. That gives you opposite values, okay? And its origin, it's symmetrical about the origin, okay? And that's pretty much some fun facts about the sine of x, okay? As far as cosine, look at the difference between sine and cosine. So as far as cosine, the domain is still all real numbers. It's infinite on both ends. Your range is still -1 and 1, except the difference is if you look at this one, your y intercept starts at 0, 1, okay? But if you notice, it goes as far as 1 to the top and as low as -1. So it's still the same range, okay? Again, our period is 2 pi. We're only looking at this much of it. It would be impossible to see the entire graph because obviously it's infinite on both ends, okay? X-intercepts. Notice it crosses the x-axis at -pi/2, at -3 pi/2, sorry, -pi/2, pi/2, 3 pi/2, 5 pi/2. So basically every how should I say this? Every multiple of pi/2. Okay. Yeah, hopefully that makes sense. I'll explain it. Basically, it's whatever pi/2 is times the multiple of pi. That might be explained a little bit better, okay? All right, and your y-intercept, I already said it's at 0, 1, And now this one's odd, this one's even. Okay, and here's the reason why this one's even. If you notice, if I were to pick a value on the right side, for example, pi over 2, my y value is 0. And if I pick its opposite side on the other side, negative pi over 2, its y-intercept is 0. So when they're the same, it's considered even. You actually learn this in integrated 3. And then, of course, it's symmetrical about the y-axis. Okay? All right, awesome. Those are some things to explain. And if you're wondering, do you have to memorize all that? I'll show you how to memorize it, I guess. Okay, so here is a little chart that is on page 292. And it's actually very helpful because these are like some 5 points that help you graph it, okay? Do you have to memorize this? No, you can also write it in an index card, but it's good to know. But look, everything has pattern. So if you look at sine of x, look at the pattern. It goes 0, 1, 0, negative 1, 0. So what happens is it alternates on the y. So you have to think it goes 0, 1, 0, negative 1. So it's kind of like it's going up, down, okay? And the reason why 0 is at every other point is because that's where it crosses the x-axis. And it goes all the way to 1, and then it goes all the way to negative 1. So this would be considered maximum, minimum. And over here, this one already starts off up, high, and then goes down, crosses the x-axis, and then goes down to negative 1. So this one starts off maximum and then goes all the way down to the minimum and then goes up to the maximum. And so the pattern's just basically going to repeat itself, okay? So again, that's in your book. And then the stuff that I was mentioning earlier, it's here, okay? And this stuff eventually will just make sense by you looking at the graph. So there's not much to memorize, okay? But it's there. All right, so what I'm going to show you is we're going to start off with a basic function, and then we'll eventually lead up to adding more values, okay? So let's get started. All right, boys and girls, so I'm giving you 2 equations that I want you to, this is kind of our goal, to eventually graph this on our own by hand, okay? And all these letters represent something, okay? So if you recall for integrated 3, we did a lot of graphs that had vertical stretch, vertical compression, translated left and right, translated up and down, and had reflection. This is kind of like that. We're going to start off with some basic graphs, and then all these will eventually have all kinds of transformations, okay? So eventually I will talk about every one of these letters, okay? And all of this will mean something. So we're going to start off with something super basic, and we're going to eventually progress to this, okay? So I just wanted to bring that up so you have an idea where we're leading to, okay? All right, so let me get started with the very first problem. All right, boys and girls, we're going to start with something very basic, okay? So we're going to start with example 1, but we're going to start with the checkpoint, okay? So basically what they want us to do is to sketch the graph of y equals 2 cosine of x in the intervals negative pi over 2 and 9 pi over 2, okay? So if you notice, this is without the 2, if I cover the 2, this would be the parent graph. Now with the 2, it just means whatever the parent graph is, our y values would be times 2, okay? So this one's very, very basic. Now, what the interval tells us is we're going to start at negative pi over 2 all the way to 9 pi over 2. It's kind of like our window, okay? Now, this probably doesn't make sense right now, but it will in a few minutes, okay, when I teach you about periods. So your period is still 2 pi, okay? Now, to get all the points in between negative pi over 2 and 9 pi over 2, what we're going to call our key points, we're going to take 2 pi and divide it by 4, Okay, so 2 pi and divided by 4, which basically gives you pi over 2. Okay, so we know we have to start at negative. Let me use a different marker. We know that we have to start at negative pi over 2, and we have to end at 9 pi over 2. Okay, so we took our period and we divided by 4, so we have pi over 2. So we're going to take pi over 2 and keep adding it to get our next key point and our next key point. And you'll know when to stop until you get 9 pi over 2. Okay, so this is our first one. To get our next key point, we're going to take negative pi over 2 and add it by pi over 2. Okay, and that should give you 0. Now, take 0 and add it by pi over 2. Okay. Obviously, for some of these, you can do mental math. You don't need a calculator or even work this out, but I'm just showing you. So we get negative pi over 2, 0, pi over 2. And now our next value, we're going to do the same thing. So now we're going to take pi over 2 and add pi over 2. And that should give you, that should give you 2 pi over 2, which is the same as pi. Okay. Keep going. We're not stopping till we get to 9 pi over 2. Okay. So then we have pi, and then we're going to add pi over 2. Okay. So remember, common denominator, so I'm going to multiply by 2. And so then I have 3 pi over 2. All right, keep going. 3 pi over 2 plus pi over 2. I was going on a trend with my colors, and then I switched it up and it messed up. So 4 pi over 2. Okay, add pi over 2, because by now you'll start to get the pattern. You get 5 pi over 2. Add pi over 2, you get 6 pi over 2, which basically is the same as 3 pi. Okay, keep going, we're not done. Okay, so 3 pi plus pi over 2 is, I ran out of room, so I'm going to do it down here. 7 pi over 2. And then 7 pi over 2 plus pi over 2 should give us 8 pi over 2, which is the same as 4 pi. And I'm almost done. One more. 4 pi plus pi over 2 should give us the 9 pi over 2. Okay, and oh my gosh, you guys, I ran out of room. So let me clean up and let me show you what all our points should look like. Okay, but you keep going. You'll know when to stop to get 9 pi over 2. So let me clean this up. All right, so once I cleaned it up, I ended up with negative pi over 2, 0 pi over 2. I could see the light kind of bouncing off and making a glare, but let me move it. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, and 9 pi over 2. These are all the points that we're going to use for our graph. Okay, so I'm going to show you how to graph this, and then I'm going to show you how to get your values. Okay, so I'm going to flip it to the other side, to this side, and then I'm going to start plotting my points. Okay, so I like using the back side of this because they're pretty much even intervals. Okay, so let me use black. Okay, so this is my 0, and hopefully I have enough room. Yeah, I have enough room. So okay, so this is going to be, I'm going to have to try to write small. Pi over 2, and then pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and then 7 pi over 2, and then 4 pi, and then 9 pi over 2. Okay, and then remember on the flip side, we started at negative pi over 2. So negative pi over 2 starts here. Okay. All right, so this is cosine. So if you recall cosine, and you can look at your chart on page 292, cosine started at 1. So it started at 0, 1. But this is not going to start at 0, 1, because if you recall, we're not working with cosine of x. We're working with twice cosine of x. So this one would start at 0, 1, but we're basically going to multiply by 2. And if you multiply by 2, now you're at 0, 2. Okay, so let me use I'm going to use blue for this. Okay, so now we're going to start at 0, 2. And that's going to be our y-intercept, okay? Then you can just pretty much, honestly, it's super easy to graph next. So this is my y-intercept. Then we have our x-intercept, okay? And by the way, not only is this our y-intercept, but it's also going to be a maximum. Then our x-intercept. And so then you have to go down 2. Then our minimum. And you're pretty much going to follow that pattern. So x-intercept, and then maximum, and then x-intercept, and then minimum, and then x-intercept, and then maximum, and then x-intercept, okay? And then over here, it'll have an x-intercept. Okay, so now you actually have enough points, and hopefully you can follow, but just imagine it's, and make them curve, okay? So we're going to go up, down, up, down, up, and then down. So our viewing window starts at negative pi over 2 and ends at 9 pi over 2. Okay. This is going to make sense in a few minutes. Our amplitude is 2. That means the highest it can go is at positive 2. The lowest it could go is at negative 2. Okay. If you notice, the difference between them is 4, but our amplitude is 2. It's always the absolute value. And just think of this. It's half the distance. Okay. That's kind of a hint based on what I'm going to tell you. Okay. And again, this is the parent function. This is the one that transformed. Basically, we multiplied it by 2. Okay. And remember, cosine is always an even function. So on the left side and right side, they should be symmetrical. Okay. And that's pretty much it, guys. It's pretty basic. Okay. But I'm going to show you one more before I give you one to try on your own. So let's go to the next one. Okay, our next example, we're going to sketch the graph of y equals 3 times cosine of x. And our interval is going to be negative pi over 2 and 9 pi over 2. So super similar to what we just did. Unfortunately, they didn't give me a different example, but don't worry, you get to try some more, okay? So again, I should be able to go a little bit faster on this one. So this is my amplitude, okay? By the way, might as well just give you this right now. It's like this. Y equals a cosine of x. Your a represents your amplitude, okay? And it actually represents more, but I'll tell you that in a minute. So your amplitude is always the absolute value of a. Remember, that kind of tells you how high you're going to go and how low. So it'll go as far up as positive 3 and as low as negative 3, okay? Your period for these basic ones, just think 2 pi, okay? And I'm going to talk about periods and how to get that, okay? So remember, our intervals, like our window, we're going to start at negative pi over 2 and we're going to go to 9 pi over 2. And just like we did earlier, to get all the points in between, just take 2 pi and divide it by 4. And we already did that earlier, so we know that it's pi over 2. So we're going to go a little bit faster and get all the points, okay? All right, boys and girls, I went ahead and plotted the points on the back. And obviously, since we had the same interval and we were going to add by pi over 2, our key points were the same as our previous example. So I went ahead and plot those already, okay? Now, I want to remind you, our parent function, cosine of x, had a y-intercept of 0, 1. And us multiplying 3 times cosine of x basically just means we're going to get 0 of 3. So it's just a multiple of the parent function. Okay. Again, there's not much to do, honestly, because once you start memorizing the pattern, it's super simple to graph, at least with the simple functions right now. Okay. So here we go. We're going to start at 0, 3. Remember, our amplitude tells you how high you're going to go, up to 3 and as low as -3. So we're going to start with our maximum, and then just think we're going to go with our root. You could call it a root, a 0, an x-intercept. It's all names for that, okay? This is going to serve as our y-intercept, but it's also going to serve as our maximum, okay? And then you say, okay, root and then minimum. So 1, 2, 3. Root and then maximum. Root and then maximum, and then root and then maximum, and then root, and then I go over here and I just think root. Okay, so it may look a little bit funny. You're like, oh my gosh, where do I start? Just keep track. So just think up, and it's a curve, and then down, and then it's a curve, and then up, and then curve, and then down. So it pretty much just looks like this. You guys, very, very, very basic. Okay, we're starting off with something simple. All right, so I think I have enough for you guys to try an example or two on your own. Okay. All right.